All right, vertical asymptotes occur wherever there is a 0 in the denominator. So what you do is you take wherever the denominator is and say, in this case, x is equal to 0. And you will see what happens is there's this imaginary line. This is your vertical asymptote because the vertical asymptote is 0 because the domain goes from negative infinity to 0 along with 0 to positive infinity because inside the domain 0 is excluded. If I'm going back up to this question, I'm going to have two vertical asymptotes here. The vertical asymptotes here occur at x is equal to 2, and the other one, x is equal to negative 3. That values happen here and here in both of those. Now, along with that graph, you can also find where those vertical asymptotes are by just when you're given a function. Let's say I had x over x minus 2 and x plus 3. So even though these two x plus 3's cancel out, x minus 2 is going to turn into x is equal to 2, which will give me a vertical asymptote. Now for the domain, that means x is not allowed ever to equal to 2. So it depends on the vocabulary that you're using. If you're asking where the vertical asymptote is, you say the vertical asymptote happens at 2. If you are saying and talking about the domain, you're saying at x is not allowed to be 2. And that idea, again, from this graph is that graph is never going to have a value at that point. Now, this other part over here that got canceled out, that x plus 3, it's still never allowed to equal 0, must be excluded from the domain. And this is what we call a removable discontinuity. Now, before we graph this function, we have to talk about what a horizontal asymptote is. All right, so a horizontal asymptote happens when you have, again, a rational function where you have one function g of f over. Whenever you have a function that looks where the degree of the numerator is less than the degree of the denominator, the horizontal asymptote will give you the line y is equal to 0. Examples of this happen would be like 1 over x, 3x squared plus 4 over 5x to the third plus 10. What matters with this is that the degree of the numerator is smaller than the degree of the denominator. Whenever that happens, your horizontal asymptote is always y is equal to 0. Now, the second thing that can happen is when f of x and g of x have the same degree and the degrees match. So whenever the degree, and by the degree I always mean the largest degree, when they match, the horizontal asymptote is just equal to the ratio of whatever is in front here. So that horizontal asymptote in this case will be y is equal to a over b. Examples of this look like 2x over x plus 1. That would give me a horizontal asymptote of, that would be 2 over that understood 1. So that's just 2. If I had an example of 5x squared over 8x squared plus 10, again, all that matters is that ratio and that the exponents in the numerator and denominator are the largest. are there. So this would give me a horizontal asymptote of y is equal to 5 over 8. Just be careful that you pay attention and they don't try to miss something by order of operation. So if I had x squared over 3x plus 5x squared, remember you're always looking for these matching degrees. And whenever that happens, then you have that horizontal asymptote. In this case, that would be 1/5. All right, slant asymptotes happen when the degree of the numerator is larger. So that looks like any x to the n plus 1 in the numerator over bx to the n. In this case, the numerator is largest. It has the largest degree. So what happens with this? It's a little bit more detailed. So if I start off with x squared plus 2x minus 8 all over x minus 3. To find the slant asymptote, you have to divide. So x minus 3 is in the denominator, which makes us our divisor. So I have x squared plus 2x minus 8. And you can do synthetic division if you want to. I didn't, so I'm just going to set it up like this. So that's going to be x. That becomes x squared minus 3x. I change my signs. Then I get 5x minus 8. So I'll put a minus 5 up there. Excuse me, a plus 5. So that would be 5x minus 15. I'll change my signs. And I'm left with a remainder of 7. So now I can take my function and rewrite this. This function is the same thing as saying x plus 5 plus 7 over that divisor, x minus 3. So all of this is actually, those two are equal. That's still my function. So I have my slant asymptote. My slant asymptote is the line y is equal to x plus 5. Because this is my line, but it's not just a line, and that line turns into the slant asymptote. And we're going to go ahead and graph a few of these in the next lesson.